Right. Welcome to today's Pop Talk. And after the last discussion, which was very intensive, I can say back to business, because we're going to talk about how to ensure that our industry moves forward. A central issue here at the innovation stage at EMO 2025 is artificial intelligence. And we've got really interesting and intriguing solutions that we were presented with individual applications where artificial intelligence can be used, how processes can be improved, lack of skilled labor can be solved, our machines can be made better. We talked about automation of robotics yesterday, and what's decisive at the end of the day is how to get all this to the shop floor, to production, and what's the production of the future going to look like, because artificial intelligence has a huge opportunity to help us here. And we're going to talk about this for the next hour, and I'm really looking forward to meeting three top-notch experts, which are not only going to talk about how this can be done, but who can report about practical applications. And this is what we're going to do today. So we'll have the three experts on stage today. They will have 5 to 7 key minutes of keynotes and will tell us about their artificial intelligence take. And then after that, we'll have a discussion with them. And of course, you can be part and parcel of this. You only need to scan the QR code that you can find everywhere, and then you can participate via Slido to the discussion. So let's get to the most important people of this session. So please, let's welcome Dr. Dominik Ormus, Chief Expert Software with Siemens. Dominik can stay here, then Dr. Sebastian Schneider is with us, Head of R&D Processes with DMG Mori. Sebastian, good to have you here with us. And last but not least, Jörg Fenstermann, Plant Manager of the plant in Kassel of Volkswagen AG. So, I'll hand over to Dominik. I think he has some important things to tell us. Yes, hello, thank you very much. I'm glad that so many have come to hear our presentations, and I think that we have one of the essential topics of innovation in Europe. We hear this from China and the United States, but we have a massive footprint in Germany and in Europe, and this is what we're going to be talking about today. So, what are we going to talk about today? Artificial intelligence requires data, and this is where I'd like to start. Data are usually not national or regional, but they usually flow. We have the automotive industry as one case in point, and Jörg is with us here on the panel. I'm looking forward to the discussion with you later, Jörg. And Catena X has been around for quite a while, so these are the data in the automotive chain, and everybody will say, well, we've had supply chains since the 70s, which have been global. Yes, that's true. But we have three challenges that we would like to solve in an automated way. Whenever things go wrong, so whenever supply chains cannot be done as planned, if there are changes, and this is to achieve resilience. You remember the accident in the Suez Channel. Solving this in an automated way and having a structure of this is an essential element. So you will see this, and we have to really increase our competitiveness. So we think that this can be done in data ecosystems. And Europe and in Germany thinks that there are lots of innovations to be had in this field. A cloud is a central thing, it's a platform, and the European response is federated and decentralized. So there's only one instance which has the authorization for it, which has to do with the authorization. That's Catena X, and that's what you see here on the globe with the links. I think this is the innovation in Europe, and data sovereignty, of course, is also addressed, which is something that we hear about every single day. So Catena X is the pioneer, it's the lighthouse in not only Europe, but worldwide, I would say, and his what it looks like. So we want to be fair and want to treat it one-on-one the data with every participant and receive data according to a business purpose, compliance for regulatory issues, quality of components that can be finished, and other things. So we've also got a demonstrator, which we also show here in Hanover. We will also show it at the next Hanover Trade Show in 2026. This is an automotive battery, and it's actually global. So this maps the supply chain. Every single country has a share in this battery, and we work with standards, and we do it in a decentralized, in a federated way. These are complicated terms, but with these terms, and we'll discuss them in a minute, it's actually possible to treat data in a trustworthy way in the B2B field without a vendor lock-in for central cloud providers and others. So we do this on an industrial scale, and we do it very professionally. We don't do it on our own. We do it in the International Manufacturing X Council. We do it together, which means together with the United States and Canada and with other European partners. I'll go into Germany today. I won't go into the others, but we also work with Korea and Japan, who are very important for us in Asia, and then China and India. So that's the central message. We have a structured cooperation. We agree on industrial standards, on few industrial standards, and we work with those. So that's really the foundation for a high-quality, structured and sovereign way of dealing with industrial data. Right. And then I would hand over to the next speaker. Thank you very much, Dominik.
Auf grün drücken.
Thank you very much. Dominik has just presented data spaces industry. Now I'm going to talk about something else, data spaces for the machine tool. And I think this was the right order. We started off with Catena X, then we thought about how can we see to it that the insights from automotive industry can be carried over to machine tools. You see Industry 4.0 on the left-hand side, a topic that was started 10 years ago. A machine was taken back then, equipped with lots of sensors, and the data of the components were then distributed and shown. But the focus was on the display of the data of the machine itself. Now, due to the data spaces, manufacturing X or factory X are included. So this is about ensuring that the data that are generated on the machines can be distributed to the stakeholders, from the customers to us, but also to our suppliers, and what use cases are there and what benefit do we have. So focus is sharing data between the customers of the data, the operators of the machines, the machine manufacturer, and the suppliers. On the next slide, we've listed the 3 key images or targets that we have. And this is the benefit to the customer. Simple operation, more spindle hours because the machines can run for longer, and energy efficiency. So those are the 3 cases. What use cases do we have here, and how do they depend on data spaces? In the simplified operation, it's autonomous operation as a service. How can you ensure that machines run as autonomously as possible? Well, we develop solutions for this to see to it that cameras can be used in order to monitor the machining process and can be controlled. Then more spindle hours, that's the use case condition monitoring led services. So once we have data on the condition of components, how can we then hand over these data to us, for instance, so that we can point out to the customers that a maintenance needs to be done, or to ensure that the failure of a machine can be avoided. Third topic, energy efficiency. Energy efficiency, of course, is something that is getting more important. It was even more important probably at a certain stage, but it still is. And the CO2 costs, of course, are still very relevant. And there are some measures that we've devised to ensure that the energy efficiency of machines is increased. So when talking about brownfield, it's helpful to ensure that the data can be shared between different machines and that parameters can be exchanged. So there are three examples just to show how where you need data exchange and how to bring about a customer benefit because of this. How and where does AI come in? Well, I've just picked out 4 examples that make this clear. First topic is process preparation, the analysis of drawings. You've got an example here, gear cutting, and we have special technological cycles. So we've got software programs that have to be parameterized in order to ensure that they can be used for the individual component. Up to now, an operator had to read the drawing, had to identify the most important parameters, and only then was a parameterization was possible. We're working on ensuring that the drawings can be read automatically and the parameters can be entered into the program automatically, so that via the assessment of former programs or cycles, you can glean insights and transfer them to other systems. Then the camera is the second example. Well, of course, the image is transferred. That much is clear. And once the image has been transferred, you also want to use this in order to ensure that an automated operation is possible. Typical example, when operating a machine, that you have problems, that you have to clean dirt, and if you can recognize this with a system, then you can counteract. Then third example, condition monitoring. And I think this is self-explanatory. We'll explain this in detail later on. And then fourth example, chatbot for manuals. This means that you have a simple question. We have a very cumbersome and extensive manual at the moment where you can look for the right PDF, but this takes a lot of time. And if you have a chatbot, then you can check much more smartly what the right response is. So these 4 examples, I think, are the ones that we can discuss a bit later. Thank you very much, Sebastian. Jörg.
Ja, vielen Dank, Sebastian. Vielen Dank,
Jörg, you have the floor. Thank you. Thank you very much. Well, we have a very strong and close partnership with Siemens, and we have had some talks before this, and these examples fit in really well with our business. Just to tell you, I'm Jörg Fenstermann, I'm plant manager of the Kassel plant, which is a plant of group components, and we work with Mr. Schmal. We are divided into 4 departments. The biggest part is group components. With the topic of tech components, then we've got the platform business, we've got charging technology with Elli for the new electromobility, and we work together with PowerCo for battery cells, and here you can almost not imagine working without digital data. Next chart shows you our footprint. We're active in 45 countries, in 60 plants. 65,000 people working for us. And at the end of the day, we're a supplier for the automotive manufacturing business. So we supply parts from Audi to Volkswagen. And here you see the different components we're looking at. So this is the new world, and we come from the old world with combustion engines, with manual switching, with exhaust emissions systems, and we are in the middle of the transformation from the old world to the new world, and both the technologies and the machines and the human beings, of course, most importantly, need to be taken on board, and this, I think, is one of the biggest challenges. So what you see here is there's still the steering. On the MEB platforms, we've got axle drives that we produce in Kassel, and the electronic components and the battery frameworks, and most of all, cells. This is a very global topic. When it comes to the process chains of these components, we have cycle times beyond 1 minute, and we have very diverse machines in this process chains, and we try within the process chain to collate data. There are different suppliers. You've got the first challenge here, Fabian and Philip. So it's standardized interfaces that you need for the machines, no matter what generation these machines come from. And I think Dominic mentioned something that's very important before. How can you manage to ensure that the data from old machines can also be included and collated? And what do we want to do with these data? Of course, we want to try to exchange these data to have a self-regulating process. And there are many interesting examples that you can look at in this environment. For instance, in sites of cast iron parts, you probably don't want every pore to be detected. You only want the relevant pores to be detected, and only the ones that lead to scrap should be detected to reduce that scrap. Or another example, the self-regulating process within the gear cutting manufacturing. So we produce gears. The last manual gear will be produced. It's got 10 gears. We have 12,000 electric drives that we produce. And a gearbox, which is 120,000 gear cuttings every day. And usually they have such fine machining that every damage can lead to acoustic problems that we detect at the test bench. And of course, we want to find out where in the process chain the problem was in order to have a self-regulating problem solver. So that's the target we have, apart from many other examples. And Patina X helps us in this process. So we need secure data to our suppliers, to our customers, so that this data transfer, you have a constant traceability to look where the problem came up and how to find a solution as quickly as possible. That was my contribution to this topic. Thank you very much.
Jörg, komm gerne wieder zu uns hier.
Yeah, please do join us again. So all three of you said that data is essential, and you addressed a very essential topic here, Jörg, linking up to what others said. We need data to be able to work with artificial intelligence. Of course, artificial intelligence is great for new smart processes, but you addressed a very important topic. The older machines need to be connected to this. I mean, what type of experience do you have when it comes to these older machines? When you order a new machine, I suppose this already has the interface for all this, but you don't manufacture machines for only 1 year, but they have a longer service life. So what have you seen in this area? Well, of course, you want to keep the machines as long as possible. A product cycle of a manual gearbox was 20 years, and the product cycle of an electric drive is 5 years. And of course, the machines should be carried over to the next generation. There are different approaches. Either you have a standardized interface, or we build a standardized interface and try via Xenon or others to have an interface to ensure that the data that are rather rudimentary in some cases can be used. But for the future, it's really important to ensure that we collate as much data as possible and use the right data in order to intervene at the right point in the process chain. Yes, we'll get back to Jörg later on, because the decisive question that I hope we will be able to answer here is how much can we get in terms of a hands-on result? I mean, you're in the automotive industry, and of course you want people to be as productive as possible. Dominic, when it comes to Catena X, this is a data environment, and I mean, this is what you should stress at the outset, and you did. And what about trust? You addressed many partners. Does everybody says, oh, well, Dominic, that's a great idea. Please do take my data. So first question is, maybe you can combine Germany and other countries, because you're not only active in Germany. Answer, well, during the COVID crisis, and then in parallel there was this evergreen where we had a 3-month chaos and the chip crisis. So we didn't get any automotive chips anymore for our Siemens controls. The supply chain was really hard pushed. So we need transparency, and this only works, it doesn't work privately. If you click onto a website, then you get all the legal terms and conditions, and you can, work your way through it. But the business world, of course, has to read everything in detail, and this is why the traditional hyperscale business doesn't really work with us. We need sovereignty as a company, as a supplier, and as a customer. Of course, it's all right for the customer to want to have data for business purposes, and then we supply these data. I mentioned some examples from the compliance area, regulation, but there are other business relevant areas, but there are, of course, regulations that we have to comply with. And then we said, well, Catena is Latin and means chain, so we said, well, let's do it globally with all the relevant partners worldwide, and I listed them before. We said, let's do this on the basis of standards to ensure that there are no islands of data that are connected with huge costs. So just a few industry-enabled standards and connectors. That's what's new. The semantic description of who am I, type sign, check that box, and so on, administration shell, and all. But the connectors for these data, wherever legal principles are complied with, is EDC, for instance. This is something that we didn't have, and that's what we started, and we're doing this globally. This is an innovation from Europe, and we are not dead in German industry. We are still working on this, and this is a real offer for the hyperscalers amongst us. And I can only ask anyone who wants to do this to join us. And then another thing, after the success in the automotive industry, because in China 100 data spaces are being set up, and one of them is Catena X, 99+1. And I think that's rather essential, because China is not just anybody when it comes to production, and I think Jörg just said it, China is essential for production. So we started with this, and how can we get this into the shop floor? And we'll talk about this later. Oh yes, of course, we need to discuss that. Just one sentence for the business motivation. Jörg just mentioned this in his presentation. This fits in with circular economy. Brownfield means that you already invested somewhere, and for good business reasons, you have to continue your investment. One example is combustion engines. Do you invest into new plants? Well, you have to check, of course, whether some models are phased out. You want to leave your plant in operation for a longer time, and used machines is is an essential topic. And if you have a operating business and machines that still fit in, and the modern machine is improved with new control technology that is internet enabled, but that has edge technologies and is within a controlled data ecosystem where the standards are inbuilt, where I can rely on productivity being maintained, where all the liability issues are complied with and the certificates, then we're in the right direction. So for us, circular economy, this topic is really something that's business relevant. We let things live for longer, but in a structured way. And I think this is the innovation for Germany. That's my essential point, and that's why it's so important to have Sebastian here with us on stage. Okay, let me link up to that, because you said condition monitoring was one use case, and I'd like to address that, because when it comes to upgrades of machines, it will be essential to know how can they be upgraded and monitored, and how far is data exchange possible. Imagine there's a machine in the field, and you could say later on, due to the data that we have in the flows, how many of them can be updated? Answer, well, in Factory X, there's a use case which is called circular economy, and we look at specifically this together with Siemens. We've developed an app where the condition of components is queried, and then you've got suggestions for solutions for the individual components, whether they have to be exchanged completely or whether some of them can be used in the future. This goes into the direction of condition monitoring. So the condition of components is not only interesting for circular economy, but also in terms of condition monitoring from day-to-day business. You address this topic. Machines usually live for 20 or 30 years, and although we've made great progress in all the wear and tear parts over the last years, the wear and tear parts usually don't last 20 to 30 years. So this is where condition monitoring comes in. So, and this is where this data space is also relevant. We get the information earlier from the machine, namely the information that a component needs to be exchanged. We can do this spare part planning. We can schedule the planning service with the customer so that we don't have any downtimes. And that's the idea behind condition monitoring. Okay, and that brings us back to Jörg. When it comes to standstill, I don't know what a minute of volt costs, because this is a kind of buzzword when you talk about these costs per minute. Let's just think of just in time, which was introduced, a very cumbersome process, and I don't think you had the IT infrastructure that we have now. What about the interface to artificial intelligence and the available data? You as a plant manager, how do you see the supply chain? Is there an end-to-end process already, or are you in the process of making it clear to the supplier that you need the link so that your artificial intelligence can do its work at all? Well, we are in the process of system transformations, and sometimes you get a bit concerned when doing this switch, this changeover. There are advantages of the new systems, but the changeover from the old world to the new and the losses that occur, and minimizing these losses to ensure that this changeover can work anyway, that's the major challenge. And it's really important to make data transparent, for one thing, and having digitized processes run parallelly to validate them, to ensure that the data of the new system match the legacy data, and to at some point say, okay, we'll go live now and change over to the new systems and then use all the benefits of the systems for instance, when changing over to SAP. And we have 12,000 employees in Kassel. We have so many different products and process opportunities, the regular process for parts. There are other processes for rework, or where a part is taken out and put back into the loop, where a control has to be done, where traceability to the supplier needs to be ensured, because these are really the topics that come up in the course of the implementation. And we try to ensure that all this can be made so transparent that you don't have any production losses, but that you continue with your production and that you still, at the end of the day, have traceability, that you know where your problem is in the process chain, where does it end up, how can I avoid this, or to know beforehand there will be a gap in the supply chain to the supplier. Suez Canal was a good case in point. And to have alternative processes that you can activate to ensure that production losses can be avoided.
So you're well connected to China, and we're familiar with the historical background. Now, if you compare your factory to your Chinese partner factories, and if you focus on the use of AI in processes, for instance, production planning, quality assurance, all those things, where it's already used today, are your Chinese colleagues in the group much more progressive and more advanced than you are? Yes and no. We began in the components factories, setting that up in China. That was the end of the 90s, basically, with machines that would be called new today in the factory in Kassel. So it's a generation of machines that generate data according to a certain standard, because the standard was made here and implemented there. And the data transfers in China, well, they're faster. You don't know always whether they're more valid, but in the private sphere in China, that's the case. Basically, there you can access data much, much more quickly. And you've got to live with the fact that your personal data, too, is available to who knows whom. There are advantages and disadvantages to that. I've seen this dynamically and experienced myself. If you look at the biggest airport in the world in Beijing and see how fast it was built and how quickly data is transferred from people who want to fly. The moment you arrive, face recognition and so on, you've got to want that. But I think there's no way around that nowadays. All technologies are being used in order to keep up there, so that our technologies that we have here in Germany can be made competitive, because at the end of the day, we've got to have competitive processes with a brownfield site, and ultimately with solutions that you can use to fix old machines, bring them up to the newest status. Thank you. That brings me back to you, Dominic. You produce machines and you develop machines. Sebastian, sorry. You help develop the machines. Now, all of these functionalities, the interfaces, you install those and you can get the data there, and you think one step further. You're the innovative motor. Don't customers say, oh, there are too many data interfaces there. Dominic wants to have them, but Jörg says, no, sorry, that's too much exchange going on, in my opinion. We don't want to have that. Do you have customers say, we want more of this functionality to use it for AI and so on? Well, there's both. I think there are customers who want the data interchange, but there are other customers too. It depends on the industry. Is it military or aerospace? They're very critical. They don't want data interchange, or at least it should be very restrictive, and there are major demands for that. And we're working on coming up with solutions for them too, so that AI can be used, but maybe not necessarily with too much data interchange, so that everything is kept in the company, on the shop floor, and then we can offer companies that they can use for their own companies. Do you supply the AI solution? You've already got the preconditions for that, so does the machine come with an AI solution? Well, we're working on these things. A lot of the examples are being developed now. I think there are one or two smaller solutions. That's chips, collections of steel chips that should be recognized, and then there's a nozzle that is used to get rid of them, and there's a product for that, but most products are still just being developed, but they're going to happen. Great. Okay, Dominic, question for you. We talked about China, we looked at the global level, you talked about that too. Now, there are many players involved here. There will be some very reactive ones. They'll say, Dominic, sure, we'll do that, here's my data, and the others will say no. Can you maybe categorize who is in what category, who's very progressive and who's not? No, of course we can do an international comparison, but we can also look at the value chain and talk about that, philosophize about it. Tell us. Well, I think I'll have a three-part answer because I don't think one answer will really be enough. I'll begin with the last thing you mentioned. Sectors, segments. We call them verticals, and for decades they have digitized their supply chains very professionally for all this time, and their culture, their corporate culture is much further ahead. Automotive, aerospace. You can't get a component nowadays without traceability. In fact, in some areas it's even legally mandated, safety-related parts such as brakes and so on, and it's similar like in aerospace. So there are other areas too, trains, pharmaceuticals, others. They're used to that, and they're used to working professionally with sensitive data. And it's about data sovereignty too. You read about it in the media all the time too. How can Europe have data sovereignty? They are leaders. They've got the culture, the process in the company. They have trained people working for them. They're leaders, pace setters. And that's why it was obvious to begin with Catena X, because it was obvious in order to have some quick successes. And we do that. Volkswagen is one of the leaders, if I may say that. You have BMW, Mercedes, I could continue with that list, Renault and others. They really are proactive in this. And then that will go on down through the supply chain of these companies. Yeah, we can make a check mark there that there's processes to go through, but we can check it off. Now in machinery, it's very different. There are lots of special machines that do very special jobs, and they're highly specific. Now the advantage for DMG Mori is that they're general machines. They're market leaders. And of course that's great because that's where scalability happens across the board. But nevertheless, you do have this heterogeneous market, and I think it takes a lot longer there to scale it up and have it everywhere. But what's crucial for us, for this subject of providing data, that's Volkswagen, that's DMG, and other big ones that really spread that out. And this leads me to the second part of my answer. Yes, AI. Of course, AI without data is impossible. Now, we talked about brownfield sites, and we've also got new investments in Germany and Europe, so we shouldn't really talk everything down. I really want to be active in saying something against that. And the data, as I've said many times, has to be, well, that has to be done in a controlled fashion. The customer will ask the supplier, this is the purpose, and so on. And the mechanisms for that, well, we give that to them. They're legally well-founded. You can check about the terms and conditions. You've got the certificates all the way down to the calibration protocol, Jörg, if it's necessary for your product and your process. Now, this is exactly where we're going. And what you need for that? Well, you need technologies for that. So that, above all, I'd like to say this, edge technologies that can do those standards, that can provide that data. There are a great example that Jörg might know about, and my Siemens colleagues really love this. You have an edge technology for structuring the data understandably, and you can also understand what's going on if an accident happens, so you can figure that out a long time afterward. Now, try to find out from ChatGPT 3 years later why he gave you a certain answer. Now, this has got to be something that will hold up in his court of law. I'm happy that that doesn't happen. Yes, but in industry, we have to do that, and we want to do it. That is our goal, our commitment, and our colleagues with this edge technology and the edge solutions provide exactly the solutions that we need in order to go into production with this kind of thing. And then that turns out well, and then we put AI on top. Sorry, it was a bit of a long answer. No, that's good, that's good. So, AI in applications. So my question, Jörg, is this. You're from a product, an industry where you have lots of regulations for your products. Germany has been world champion in this. And in cars, well, you just can't ignore rules and regulations. It's not going to happen in the future. But in automotive, will there be more bureaucracy in the future with AI? Or maybe will you just make processes faster and approval quicker, quality assurance is done more quickly? Practical things could be quicker. What are your hopes? Well, our hope is that we can use the technology, make it usable by our company. For that, we've got to have the data at the end of the day and the right selection of data for this. But this brings us back again and again to the subject of how can you ensure that this is so valid, the digital process chain, let's put it that way, so that at a certain point in time you can take data out. Let's say you can take out quality data or maybe other things too. In any case, you want to be able to make it transparent. Certain things have to be made transparent. You've got to have end-to-end process chain, not just the data to the machine, but you've got to have the data. You have this huge pool of data, and of course, that's a risk too, no doubt about it. And for some industries, well, maybe more than for others, but for us, ultimately, it's a huge opportunity if we're able to take that data and put it to good use. Now, we're working more and more now on making this data usable. In fact, we work in the field of gearboxes. We're making the next manual gearbox or transmission, last one next year, and we're now doing more faster and faster work. Cycle times less than 1 second, so process data has to be generated extremely quickly. You've got to do regulation and control with that data. You have to have quick intervention if need be. Otherwise, you can't be competitive in your production. And there's no two ways about it. We do need data, and the data has to be interconnected with other data. And for that, we need systems that provide secure access to that data. And you have to know how to get at the relevant data. Well, maybe let's ask a question for you. Because, okay, the data world, I understand that. I'm not an expert in the details, but let's assume this. I think in one of your use cases, you talked about visual checks. Yes. Now let's take that. You could philosophize about, okay, let's use AI for visual checks. Now you, Jörg, when that part has been checked, you've got to document that because your head is on the line if it wasn't right. Now, DMG will say, we'll build a machine and it's incorporated in there. And the AI will evaluate it. You don't have to put anyone there who will check it. It's going to happen. But of course, Sebastian then will have to assume responsibility for that, at least for the data world that verified that things are okay. Do you see that's the case, Sebastian? Do you see it? Well, if it's about quality control, quality assurance, we have approaches where we're working with a startup and we take the control data to generate a digital twin, and using that we ensure quality. But here too, we've got to say that we have to learn how to handle the data. So you can't go and take the data from one day to the next and use it exactly as it is. You've got to digitize it, you've got to compare it with the actual physical measurements, and then check to see whether or not you can replace it step by step. And I do believe that in the future, with digitization and digital solutions, you can replace what's being done now. However, there will still be a need for physical checks, but you can replace a lot of manual processes. But at some point in time, we're going to have to see that. I don't know what your ideas are in Kassel, but I think every day there are 100,000 people who say we want to go work in the factory. That's not the case anymore. Production planning, quality assurance, process planning, process optimization. It's going to be harder and harder to find people with these right qualifications, and therefore you, the plant manager, have advantages if AI can do it. And for that, you need the data from our colleagues here. Without that, you couldn't do those processes. So do you think at some point in time we'll reach a spot where for certain areas we'll say, okay, AI will do that alone without people in the future? Well, I think a supplier can only do that to a certain extent. Let's put it that way. We've got some colleagues up front there who suffer from the fact that this is the case. They suffer every day. They might have a few problems in the housing somewhere, and they suffer from that. And, well, let's put it this way. We have manual checking processes, and then we set up AI, let's say. Now, the normal reflex would be, okay, let's use AI, and we'll check it using the drawing data, but we know that it's not going to be perfect. What we actually have to do is this. What people do, well, AI has to learn that, and the relevant data will have to then be analyzed and evaluated. So it's the other way around. The machine supplier would supply everything. They'd say, okay, I will check every hole, every boring. I will find out what you want. But this is actually something we only need to a certain extent. We need the relevant mistakes and errors, and this constant learning and this constant control process, implementing that. I think that's our job at the end of the day. Let's put it that way. We're the producers. Does this have any relevance for the functionality of that component? If not, we'll take it out or we'll put something else in. Now, do you give this information back to suppliers so that basically Sebastian then makes sure that this feedback is implemented, right? Because otherwise you'll start developing check machines, right? Checking machines, inspection machines. Well, we do actually do that so that we get the right methodology in there. But I'm sure that this functionality will go over to suppliers. I'm sure of that at some point in time. But this filtering out of relevant data or the level of precision required or level of inspection precision required, and then saying, okay, how am I going to control the process? And that varies from one component to the next. For some components, we have to have a zero-fault strategy, and for others, it can be done differently because that's the only way to do the process. And this is based on experience that you garner during production, during mass production. This is something that's learned, and this is something that we've got to teach to AI. Dominic, back to you. Let's have a look at Catena X, Manufacturing X, if we want to go on from there. No, I understand the thing about the data space. I'm up to speed there. But my question is this: where do we see success in actual practice? Because I'm from the field of production automation. I'm not an AI expert. It's a typical case. We've got a problem. We go into the process. How can we optimize it? That's my background. Now, I've got different partners who feed in their data. Is there a use case where we've said, okay, there we've done data analysis using AI, and different partners in the value chain have come on board and said, yes, we've got a benefit there? Are there examples like that? Yes, there are examples like that. Let me mention one, not from Volkswagen, but from another renowned German automotive manufacturer. It was just last year, just after Catena X started. There was a problem for a supplier of a cover on a component, and normally you've got 1,000 vehicles that will come back if it's discovered too late, or even more. And that was reduced to 346. The normal chain would be emails, phone calls, and so on. That was the conventional way. Rather than that, they used the alarming function in Catena X. The supplier achieved transparency, and there was a sample check, and I was talking to Jörg about that. You never have perfect material. You want to find the right errors, the right holes, the right gaps. But you need a system integrator for that. At the automotive company, you can say, here's something, we found something here in our quality check, stop everything. And these vehicles, they were identified, and almost none of them had been delivered to customers already, less than 10. And the rest were in the supply chain somewhere, external or internal supply chains, and they were handled ahead of time. So it was a massive cost reduction. It was ideal, automated, on the spot, exactly what we are proposing. So from the point of view of the supplier, you have to imagine this. If you look at the old command chain, the quality guy calls up, you've got to do a report, you've got to do a 100% sample and a check. Yes, and then people are on vacation, and then it gets stuck somewhere, and people don't take care of it, and then it lasts 4 weeks. So basically, we can hope that automated processes are kicked off that really jump past all of that, which in the past used to take lots of different steps and would have led to a standstill of the line. You can limit that. You can start certain activities ahead of time. Now, let's go one step further. I'm interested in this. Let's say, let's allow AI to make recommendations for actions. Fully automated process. Let me think about this. AI says, okay, I've got to inform these 5 dealers because there are a couple of vehicles there, and I've got to say to Jörg, you've got to stop your production. Is this conceivable, Jörg, or even desirable? Well, let's forget desirable. What about conceivable? Well, there are certain faults which only happen in certain parts of the world. And for that, there are systems, too, that we use more and more in order to find out what the relevant environmental conditions are, driving conditions, how the people drive cars, people that might actually be the cause of the fault. So analyzing that, well, that can be done. Ultimately, well, if I would say to my quality assurance colleagues, I don't know, you're going to be replaced by AI. I don't think that's going to happen in my generation. I'd like to answer that, if I may. Jörg, I agree with you. I'd like to add something, though. How can we get to industrial AI? Well, for that we need models. Let me tell you about an article in the German newspaper Handelsblatt in which Siemens announced that they're working together with numerous renowned German machine tool manufacturers. And I think the difference between how you use AI, privately ChatGPT, and so on, if you do a translation or whatever, generate a text, there's a difference between that, a fundamental difference between that and how it's used in industry. We'll have AI models that are domain-specific, but for that you need lots of data. And per individual user machine, it's not enough. It could be enough. We talked briefly initially about the special machines. That's a different area too. It's important. But I think that we've got to have these models across the industry, across all suppliers or manufacturers. And I hope you understand. Data exchange in a spirit of trust, sovereign data, where we'd have in a data ecosystem where we have total control, not with a lock-in effect for one manufacturer who just keeps that data. The data really stays with the component suppliers, and they update it over the life cycle. The supplier puts in there what's been done, torques and so on, what's been bolted together. Jörg can tell us a lot about that. But if we, a number of machine manufacturers succeed in generating the data for an entire domain, we have a huge asset. I don't think it'll be enough in the future to do that per individual factory or company or machine. That won't be enough. Generalization won't be enough if you want to generate models for that. We've got to learn with cohorts, federated learning, on the basis of structured data. That's extremely important. So we don't want to have the bias effect that you normally have in AI. We definitely do not want that in industry. And then we can answer your question and say, could we depend on what AI proposes to us there? I think then, under those conditions, yes. And that's where we've got to work together. I think that's an immense strength that we have in Germany and Europe. It is a huge asset, and it's another innovation we can provide. We don't have to hide at all behind the United States or China, because we can be strong there. That's a strong statement I can make. Well, that's something that would strengthen our competitive position. But what about you, Sebastian? You sell not just in Germany. You're international. Now you're an international player. You're also a data supplier in that cosmos. Now, it would be in your interest in doing it not just from a German or European point of view. Ideally, it would be global, right? Well, on the one hand, we produce for other countries. About 75% of our machines go abroad. That's the one point. And we developed on a multinational level. We've got sites in Japan and in Germany and Poland. And so, therefore, we've got international standards. And one of the core points for Factory X and Manufacturing X was that from the word go, we decided to focus on internationalization. Dominique presented that, the International Manufacturing X Council. And there, what it's about is ensuring that the standards that we are developing now in Factory X are then communicated to all countries, so that there too we can get an agreement on how they should use the same standards too. That takes a long time. You can see that in other examples as well, but we're doing interchange of ideas there, delegation trips. In October we're going to Japan and South Korea because this is very important. And we've been to other countries as well, for instance, Poland, India, and there too I think we've put together a good consortium of countries to make this an international success. Well, if you're doing international interchange, Sebastian, do you have the impression that some have made more headway than we have here? Now, if you look at the company level, sorry, Dominique, but if you go down to the company level, what international partners are better at this? Well, in general, we can see that in many countries there are activities on this, but I don't think we can say they're better or they've made more headway. I think what's important is that we make sure that everyone talks together and we all develop the same standards, because the problem is this: if everyone starts running at the same time, they might run in a lot of different directions. And so what's most important is that we have everyone running in the same direction so that we can develop common standards across national borders, but also across different industries, because Catena X, that's automotive, there's aerospace X, aviation and normal mechanical engineering, energy technology. It's something for a lot of industries. Well, I can only say I'd be very happy if we could agree on a standard. I know from the past that when it's a question of international standards, if things take too long, well, somebody will just start doing it and set a standard by market power, VHS and so on, things like that. What then was the standard was whatever sold best. They were the leader, so I hope we can get an agreement here quickly. We've got 3 more minutes. Let's look to the future. I'll begin with you, Dominique. You get 1 minute. Go ahead. 1 minute, Dominique. Let me warn you, I will cut you off then after a minute. Go ahead, though. Where do you think we will be in a couple of years? Now, I'll give you a number. Something I don't want you to give us a number. I learned in AI that doesn't make sense. But what do you think the big steps will be that we're going to be making here? Well, AI models have got to be learned for our verticals, for our applications, which help support us in automation. That's crucial. I mentioned the preconditions for that. Another precondition is that in edge technologies, we have to remain leaders in Europe. We've got to do certified controlled edge technologies. We companies offer that. All our competitors see that too. We can't push that enough. That is where our AI will be running. That's my answer. Great. Sebastian? Well, my opinion is similar. With Catena X, we've shown that data exchange on a horizontal level works well. Factory X, Manufacturing X, that's for other industries and also for vertical. And by next year, we're going to be implementing that, and the use cases will be implemented. The next big step, I think, is AI. In other words, the data that we've learned now, that we can interchange, how on the basis of that can we come up with use cases and products that we develop. Great. Jörg, I've got to say one thing before I ask you about your ideas for the future. Now, you've got an advantage. Well, those two can as well, but you are really on site because you can go onto the shop floor every day, and you've been doing this for a while. Give me your vision for the future, where you see AI in the future, because we're seeing a wonderful base coming up here. Where do you think it'll be in a couple of years? Well, I hope that there will be data in a certain quality across the entire process chain from the supplier to the customer that we generate, and then with this data, and this really brings me to the European solution, it'll be a data quality that'll make us competitive in Europe again, so that we can be very quick in reacting to certain things, and then in terms of developments, we can be even faster too in our development, in our engineering. AI, that's one thing. Okay, production should be made transparent and self-regulating when data is available for all processes all the way on back to the supplier. In addition to that, we want to have AI models for, let's say, electric motors based on findings from the past, and then you'd have proposals for our engineers and how to react to things, so that you have to realize that a motor has 20,000 RPM, not like an IC engine with 8,000. So there'll be different subjects, sound, noise, acoustics, things that are brand new, but the knowledge about this has to go into the new drive systems. This will be the same for all different things: efficiency, driving, behavior, handling. So we have to be able to access the data which becomes available and will make us more competitive step by step. This together with the suppliers that provide us with machines and with components. Great. Well, that's a great final word. Ladies and gentlemen, Dr. Dominik Romes, Dr. Sebastian Schneider, and Jörg Fenstermann from Volkswagen. That was a good wrap-up. Sensational. Thanks to all of you. Let's give them a big hand, ladies and gentlemen, for our panelists. A big hand.